between Professor Branover and his colleagues and this particular conference, which is held here and which will now be held in 2004, the next one. At which time various scientists, all of whom who are from, make their case for scientific theories and how they actually work when you examine them through the light of Torah. So Professor Avi Rabinowitz, who very kindly has come to see us today, was born in Maryland and raised in Canada, and he lives both in New York City and Jerusalem. That's an enviable description. Some of us would like to do that. He got his Bachelor's of Science in Electro-Optical Engineering at the Jerusalem College of Technology and his Theoretical Physics Doctorate at NYU. And now he is a visiting scholar at NYU. He's published a great deal on a variety of topics in physics, theoretical physics, which are way over my head and I assume will be way over yours. But the reason he's here today is to give us a handle on how to explain the Big Bang to the kind of people who come to this museum and to show us how to handle the various questions that might come up from very firm people who don't know anything about it, who immediately think it's trade or papyrus stuff, to people who are genuinely interested in how you could reconcile the Bible's theory on creation, on duration, with the Big Bang, and what the Big Bang means. Now, Vitaly Komar is one half of the artistic team, and he's sitting in the back, and he has produced, Komar and Melamed have produced this body of work on the Big Bang and Jewish symbols and how they relate. And Avi has already done some work in this area, so it's a very nice tie-in. For Komar and Melamed, it's their first foray into Jewish, so-called Jewish art. And I think this is another chance for us all to expand our education so that we understand that art is not just about the visual image, but it's about history, archaeology, science, literature, anything, in fact, that takes the mind of the artist and in which the artist wants to interpret visually any discipline at all. And that is why we brought Avi Rabinowitz here, so it's my pleasure to present him.
Thank you very much.
Avi's going to be taping his own presentation, so that's what...
I hope possibly to make this available to people who want to be able to review the lecture. I know that I'm going to be throwing lots of material at you, and for those of you who don't have a large amount of science in your background, it might be a little bit much to handle. I certainly will be glad to have questions at the end, and I have a number of references for further reading that I'll be glad to make available to you. And I think that the scientific concepts that are required to understand the material are relatively basic, so please don't be frightened. I don't know if you have to be frightened about any kind of theological problems that some people do, but I hope that the science won't deter you as well. First thing, what is the Big Bang Theory? Why do people consider it problematic? And why do I and many other people in the science community who happen to be Orthodox as well do not consider it problematic? I would say, as a matter almost of protocol, the universe is old enough, maybe it's lying about its age. I don't know. You know, if you confront a universe which claims to be 6,000 years old, would you say, no, I can see behind the mass, you've got to be at least a few billion. You know, maybe that's not polite. But there always were discussions and arguments and differences of opinion between philosophers of any given period of time and the religious conception of the creation of the universe as we have it in Genesis. Even though perhaps Noah had a tradition as to how the universe was created, right around the time time of his death and soon thereafter, the world was basically pagan. It was the time of Abraham, which we're studying right now in the portion of the week. And we can certainly visualize Abraham conducting all these kind of learned discussions with the metaphysicians and philosophers of his time. And we do have, in fact, records of the ancient Near East. We know what were the conceptions of the creation in ancient Babylonia and etc. And they are certainly not exactly the same as Genesis. So clearly there always were these differences between what the rest of the world conceived of how the universe came into being or why it came into being and what the Torah teaches. It's not something new. 1,000 years later, more than 1,000 years later, the Greeks began to originate their very fascinating ideas of how the universe originated, if it originated at all. And back then there were discussions between Jewish philosophers and Greeks, and some of these are recorded in the Talmud. So again, this is something that one can trace all the way back. It's not a new issue. I would say it never was an issue. And at the time of the ancient Greeks, the philosophy that gained most credence was that of Aristotle, eventually prevailed. And that was that the universe as a whole is eternal in time and infinite in extent. It goes on in any direction forever. And it always existed and always will exist. They had what they felt to be very, very good reason to come up with this idea. And there were other conceptions that the universe may have begun to exist at some point in the past. But eventually the force of Aristotle's arguments defeated all the opposition. And for over 1,000 years, philosophers and people who today maybe we would call scientists accepted this version of the origin of the universe. Part of it had to do with logical thinking. If someone were to tell you that the universe is not infinite and extent, you would say, well, then the universe must come to an end somewhere. If it comes to an end, well, what is there at the end, and what is beyond the end? Can I stick my fingers out after the end of the universe, and then what's there? By definition, if I can put my hand out, then the universe didn't end, because I define universe as everything that there is. So it seemed totally impossible to think of a universe that was finite in extent. It had to be infinite. And for philosophical reasons, it seemed almost impossible to imagine a universe that came into being at a certain point in time, because what was before that time? And even according to the metaphysical speculations, which in that time was considered philosophy, if one imagined that the universe existed because of the existence of some kind of supreme being, or the ground of being, as perhaps maybe philosophers would have put it then, if that entity was eternal, then that entity probably does not change its mind and have whims and sudden desires and fancies. And therefore, if it desired that there be a universe, it would always have desired that there would be a universe, and therefore there always would have been a universe. And therefore there would always be a universe. So the universe of necessity, even to those whose conception of the universe included some kind of metaphysical entity, a ground of being, necessarily concluded that the universe was eternal. And this conception continued on for over 1,000 years up until medieval times. And about 800 years ago, the great philosopher and sage Maimonides, Rambam, wrote an entire work, The Guide of the Perplexed, whose basic fundamental thread running through the text was to talk about what today would be considered science and religion. At that time it was maybe more philosophy, metaphysics, and religion. And Rambam's main point in the book was that although Aristotle's arguments were convincing to some degree, they were not logically totally convincing enough that we should reject an idea like the creation of the universe as a result. What he did say very clearly was that if Aristotle's arguments would have been more cogent and would have been entirely logical and irrefutable, then there would be no religious necessity to reject them. There would be no religious necessity to understand Genesis as implying that the universe came into being at a certain time. In other words, in line with Maimonides' general position that there is much in the Torah that should be understood in an allegorical method, not to dismiss any of the commandments and so on, but certain of the more philosophical statements about the nature of God and so on should be understood allegorically. He said that it's certainly possible that Genesis is also meant allegorically. In fact, he mentions explicitly many things in Genesis that are allegorical. And one need not consider this to be a fundamental tenet of Judaism that must hold in the face of any kind of convincing evidence. I'm quite sure that had he lived now, he would analyze the Big Bang Theory and any other kind of scientific conception, and he would come to his conclusions, whatever they would be, whether or not they were convincing or not convincing, and come to a determination in that respect. The Torah is based on revelation. God reveals truths to mankind, and then man passes it on through tradition. Science works exactly in the opposite way. In the way that perhaps Descartes began modern philosophy and said, I'm going to disbelieve everything, I'm going to mistrust everything, I'm going to doubt everything, and he started from that point. What can I know without relying on something that someone else told me? Of course, he very quickly strayed from that path and came up with a whole philosophy that is not necessarily based on fundamental truths, but he did begin a trailblazer in that way. Modern science works in a similar method and says, tradition is very nice, revelation is very nice. I want to know, what can I know about the universe based on my own explorations, my own thinking, and that I can verify through experiment, and that everyone will agree upon, whether they are a Satmar Chassid who happens to be a physicist, or they're a Chinese communist who happens to be a physicist, they will agree on these results. And that's really something quite beautiful. Now, there are many kinds of truths that people will not agree about. Clearly, religious truths, political philosophies, and so on, they're not going to agree about. But science limits itself to those things which can be independently and objectively and universally verified by people independent of their religion, political philosophy, and so on. And as such, I think it's actually a very noble pursuit. However, it does, of necessity, limit you, and it, of necessity, denies information that comes from other kinds of sources. Now, at the time of Maimonides, there was not yet the scientific approach, the scientific method had not yet been developed, and people tried to come to truths about the universe, about the meaning of the universe and life, through independent thinking rather than through experiment. The modern scientific era began around 500 years ago with, for example, Copernicus and Kepler and Galileo and Newton. And their theories have great relevance to our scientific conceptions of the universe in general, and specifically to the Big Bang and to the origin of the universe. So I'm going to go a little bit into those theories as a precursor to the Big Bang, and I hope that I won't lose you. Sometimes I hear from people, oh, your lecture was terrific, I didn't understand anything. That's not a compliment. That is definitely not a compliment. I hope that I won't lose anyone. At the time, before the beginning of the scientific conception, people did not have access to telescopes. They didn't make careful measurements. They didn't think of using equations, mathematical equations, to try to predict phenomena and thereby verify what their theories said. They basically built things on speculation. But they also had careful observation. For thousands of years, people looked at the night sky and saw all kinds of lights in the sky, what we know today to be planets and stars and galaxies and so on. And they realized that some of them are moving, some of them don't seem to be moving, some move very, very slowly over a period of years, some move every day, etc. They catalog these, and they try to come up with an explanation. What are these things? What are these lights? Where are they? Why are they there? Why do they move? What moves them? And basically the conception of Aristotle all the way up to Maimonides, and Maimonides ascribed to these as well, was that whatever was outside the earth, and I'm generalizing a little bit, was heavenly, spiritual bodies. And the planets that we know today to be just rocks, basically, were heavenly bodies moving around in circles around the earth. Now, everyone observes on earth, when you move something, it moves in a straight line. Things don't naturally just tend by themselves to move in circles around and around and around continuously unless someone is pushing it, or unless it's an intelligent being that decided to go around in a circle. Their conception was that a circle is a perfect geometrical figure, and therefore all these entities move in circles around the Earth. And the reason that they're understanding enough of metaphysics to know that a circle is a perfect shape and desirous of moving in a circle is because they are spiritual entities and they are carrying out the will of the grounded being or the creator or whatever it may be. When Galileo turned his telescope on the planets and was able to observe that they are rocks, they are matter, no more or less spiritual than the planet Earth, this was a fundamental revolution in our understanding of what the universe was. When Copernicus showed how much simpler it is to understand the universe if one thinks of all the planets and the Earth rotating around the sun, rather than everything rotating around the Earth, this was also a fundamental revolution in people's conceptions. Now, it is not true that there is any theological implication of necessity to any of these scientific theories. The fact that the Earth is not the center of the universe does not mean that there's no God or no creation or that humans are unimportant. However, because people erroneously attributed the theory that the Earth is the center of the universe and everything goes around it to religious sources, and it's not part of religion, because they attributed to that, when those theories were overturned, people then said, well, religion has been disproven. Mankind is not important. Mankind is just some kind of accidental figure in the universe. And I think it's important, therefore, to be more minimalist, not to look at scripture, text, and to say, well, this is totally meant literally, and this is what it means, and to project your own understandings into what the text says, because you're probably misleading yourself and others. And there's also a danger in that, because you may be proven wrong, and then you have shaken someone else's faith in what is actually true, because you've given it a layer of untruth. What Galileo realized about nature is that although on Earth we see things move and then slowly come to a stop, the reason it comes to a stop is only because there's friction. There's air pushing against it, it's moving on the ground. There's always something obstructing the motion, and that's the reason that things come to a stop. Left to their own devices, nothing would go to a stop. Things would continue forever, particularly, for example, in a vacuum in space where there's nothing obstructing anything. There's no reason for them to stop. Now, what would happen, for example, on the Earth if I throw something up, it comes down. If I throw it at an angle, it goes in a trajectory like this and comes down. If I throw it harder, faster, it'll go that much further before it comes down. Imagine that I throw something really, really, really fast. Maybe I shoot a projectile from some type of a ballistic rocket or a bullet or something like that, and I shoot it straight out. Now, we know the Earth is curved. If I shoot it straight out, if I shoot it fast enough, before it manages to fall to the ground, maybe it'll kind of miss the ground. It'll miss the Earth and go off like that. Okay, but eventually probably it would hit, like over here on the other side. Okay, again, here's the Earth. We're shooting it this way. It's trying to go to the ground, but it's going so fast that it kind of hits the ground over here. You can see the possibility that if I shoot it fast enough, what will happen is that it will kind of escape the Earth. Now, I can shoot it and it goes far away, or what could happen is it goes into orbit. What does orbit mean? Orbit simply means that it's falling towards the Earth, but while it's falling, it's also moving sideways because you gave it some kind of speed in that direction. So it's trying to move this way because you shot it this way, but it's also moving down because of gravity. But it's still trying to move this way, but it's also moving down because of gravity. It's still trying to move this way, but it's moving down. Here's the Earth towards gravity. It's still trying to move this way, but the gravity is pulling it in. It's still trying to move this way, but the gravity is pulling it in. If you think about it carefully enough, you'll see that there's a possibility of an actual orbit. And that is, in fact, how satellites stay up. They're actually falling towards the Earth all the time. They're constantly falling towards the Earth. We're in orbit now about the sun. The Earth is falling into the sun. Don't get panicked. Right now, as we speak. The Earth is constantly falling into the sun. Because it has a speed in that direction, though, as it falls, it goes out. As it falls, it goes out. As it falls, it goes out. And it's exactly the right speed to take it into perpetual orbit. And this is something that the work of Kepler and Galileo, Tycho Brahe, with his incredible observations and meticulous recording of all the times and positions of all the lights in the sky. And this understanding was given a formalistic basis by Newton. And what happened was something really absolutely astounding. observed that gravity acts on the Earth. We all feel gravity. We're all pulled into our chair right now. We know that things will drop to the ground. And he showed that the very same formula that describes this action of gravity here on Earth describes the force that pulls, for example, the moon into the Earth, into the orbit of the Earth. He was able to calculate, based on the formula, if I were to drop this and to measure how fast it's moving at what time and so on, he came up with a formula that described the attraction of gravity. And he applied that formula to the moon and to the Earth, and he found that it exactly predicted the orbit of the moon. And then he tried it on the Earth and the Sun, and it exactly predicted the orbit of the Earth around the Sun. And that's pretty astonishing, to find that the same simple formula that describes this so familiar phenomena of gravity also is responsible for or describes this incredible heavenly motion. And again, of course, what happened was that people said, wow, this universe is a mechanistic one. It's a naturalistic one. It's not spiritual entities moving in perfect circles because they are the perfect geometrical shape, but this beautiful geometrical shape comes out because of beautiful equations which have these tremendously aesthetic results. But it's some kind of a natural law. One doesn't need necessarily to assume that there is something divine in here. Newton himself was a believer, and he firmly believed that God had created the universe, and God had designed the laws of nature, and he saw no negative religious implications of any of this. What happened, though, is that people began to think of the universe more as a machine than as some kind of spiritual entity. Clockwork mechanisms, laws, simple laws really regulating what happens. Then people applied this understanding to larger and larger entities. Gravity works so that if you have a bunch of, let's say, a gas of material here, and it ends, so there's a clearly a roughly defined border to the gas, what's going to happen is the gas and the outer particles over here, the outer side, will be pulled in towards the center by all the mass in the middle. And the gas closer towards the center will be pulled slightly outwards by the material here, but much more towards the center because there's so much more in the center. What happens, therefore, is things tend to agglomerate into something like spheres. And that was used as a theory to explain how the sun originated, how the planets originated. And when you look and you see galaxies are essentially billions of stars held together by gravitational attraction into spherical shapes or shapes that are more oblate. And you then apply it to the next scale, and you find that there are galaxies close to each other, clusters of galaxies which seem also to be clustered in together by the same force of gravity. And you extend this further and further out, and you get to a structure of the universe, the physical universe, which seems to be determined by the law of gravity. Very, very, very simple law with very interesting consequences. Now, there were some problems with this conception of the universe, because if you had all these galaxies or planets or whatever in the universe, would they not tend to also clump into the middle? And they would collapse into the center eventually over many, many years, and they would form one big black hole, and there would be no universe left. And if the universe was infinite in time, then that would have already happened at some time in the past. So why is there a universe? So Newton was aware of this problem, and he tried to come up with reasons why an infinite universe would be stable. But this was a problem that remained until Einstein's time. There's another thing that's problematic with that kind of a theory, and that's what it neglects. When you're trying to figure out what is the structure of the universe, and you're not taking into account anything other than gravity, are you leaving something out? For example, human beings, love, life, meaning, purpose, spirituality, art, literature, philosophy. Are those important somehow to describe the universe? Or are those just incidentals that arise out of a naturalistic universe? Humans arise, and the natural activity of humans is to engage in those kinds of things. Or is that something fundamental to the universe, something that tells us something basic about the universe, and if our theories of the universe don't take it into account, maybe we're missing something very fundamental. There's something scientifically, though, missing in that theory. what is that theory about? That theory is about the matter in a pre-existing universe. There is an infinite universe, eternal, and in it there is matter, and gravity kind of dictates how that matter will interact with each other. But what about the universe itself? What about that which all this matter is within? Without having a theory of that, you don't really have a theory of even the material universe. And that's where Einstein steps in. Einstein's theory of special relativity dealt with showing the connection between space and time, so that people now talk about space-time rather than seeing them separately. And he showed that matter and energy were fundamentally related, and most people have heard of E equals mc squared. The revolutionary insight there is that energy can be turned into mass, mass can be turned into energy. In other words, they're basically fundamentally the same thing, matter and energy. They just take different forms. Space and time are basically the same thing in some underlying sense, and they can be turned one into the other in some fundamental sense. What his general theory of relativity did was to combine those two, to combine space-time and matter-energy into one fundamental unit. And he showed that matter-energy warps space-time, affects space-time. Now, I won't go into that very much, but for those of you who want just a little bit of a glimpse, the nature of space, for example, the fact that if you draw two parallel lines, they go off parallel all the time. You know that if you draw a circle of any size and you measure the circumference of the circle and compare it to the radius of the circle, you'll always get the same number. It's always 3.14, etc., pi times the radius. 2 pi times the radius. No matter how large your circle. And this is a beautiful geometrical truth, something that people knew in ancient times. And it tells us something about the nature of the universe, the nature of space. Now, it turns out that mathematically, there's no contradiction in a mathematical universe, so to speak, in which parallel lines do meet, in which circles don't always have that same ratio. In other words, where space is warped. The question then became, could it be that the physical universe could also have similar properties? Who said that the physical universe has to be the same as that one particular mathematical type of space in which parallel lines went like this and circles always had the same ratio? Who said? Who said it's limited to that? And there were attempts at the end of the 19th century actually to measure this, and they failed. Einstein's theory was a theory which in fact showed that this was the case and why it happened, and gave an equation to exactly measure how much warping there would be. Now, something very radical that came out of this theory was the idea of the finitude or infinitude of the space of the universe that we spoke about earlier. In a mathematical space, there's no contradiction involved if one says that a mathematical space is finite in extent, it's not infinite. And in other words, one can go in this mathematical space in any direction and come back to the starting point without saying that it's a, for example, if you have a sphere, right? If you go on the surface of the Earth, you'll always come back to the same point if you go straight all the time. But we know, of course, you're not going straight. We know you're going around in a circle because the Earth is spherical, right? Because we can see it from the outside. But a mathematical space talks about all the space that there is. Not that you're talking about some limited part of the space which is actually circular, and that's why you're going in a circle. But the space itself is warped, so that if you go straight in that mathematical space, you come back to the same point. And the physical universe was shown to be also possibly the same, so that in whichever direction you went in space, you could come back to the same point without ever reaching a wall. Not because we are in some larger space where if you stood there, you would see that we're in some kind of sphere. But all the space there is, spatial relations are warped. And it's a staggering concept, but there's absolutely no paradox involved. We're just used to a flat space and to parallel lines not meeting and to having things come back to themselves only if you can see that it's a sphere. Now, what this meant is one of the major conundrums about the universe was shown to be not a problem. The universe doesn't have to be infinite. On the other side of the coin, where the universe was considered to be eternal, Einstein's theories also blazed the way to show a resolution of that, and that brings us up to the Big Bang Theory. could take, just as a model, let's imagine the galaxies, like little dots in this room, and I would say that space is expanding. What would that mean? What I mean by that is that not necessarily the galaxies are expanding, but somehow the space between the galaxies is getting more, so that each neighboring galaxy is getting further and further from the other. So that the distance between galaxies is expanding without them moving. They're not moving, it's just that the space between them is expanding. Now this again is a radical concept. You can kind of illustrate it in a little bit of a model. For example, the surface of a balloon. You paint little dots on the surface of the balloon. As you blow up the balloon, the dots will obviously get further. Now, if you think about it, if you try to come up with some kind of mathematical relationship, you'll see that, let's take neighboring dots. One dot, another dot, another dot, another dot. Okay, here's another one, another one. Each dot is, let's say, a galaxy. Now again, I'm painting them on the surface of a balloon, but I'm not saying that these galaxies are in a sphere in that way. We're just talking about the universe as a whole. And the universe is the surface of this balloon, not that there really is something else outside our universe. It's just a model for understanding what's happening. Now, if you take adjacent dots, let's say they're an inch apart, okay? And let's say over the next second, as you're blowing up the balloon, they move from 1 inch to 2 inches. So the distance has increased by 1 inch in that second. So the speed that it's been moving basically is 1 inch per second. If you look at the next dot over, if this was 1 inch and this was 1 inch, and now this is 2 inches and this is 2 inches because each dot is separating, right? So this one was 2 inches away from this one. Now it's 4 inches away from this one. So again, you have these 3 dots, a 1 inch between them. Now there's 2 inches between them. So in terms of the distance from this one went from 1 inch to 2 inches. This one went from 2 inches to 4 inches in the same amount of time. So this one was moving away at 1 inch per second. This one was moving away at 2 inches per second. And if there was another one here that was initially 3 inches away, and now it's 6 inches away, so it went 3 inches in that second. So the closest neighbors move away at 1 inch per second, the next neighbors move away at 2 inches per second, and the next ones move away at 3 inches per second. And that's true for every single one. And it doesn't matter where you are. The one that you say is moving away from you at 2 inches per second or 3 inches per second, from their viewpoint, would see everything moving away from them at 1 inch per second, 2 inches per second, 3 inches per second. In other words, in an expanding universe, what one would expect to see would be all the galaxies in every direction moving away from us with larger and larger speeds corresponding to their distance from us. And this is a staggering projection to make onto the universe as a whole. And in fact, measurements were made, and this was found, in fact, to be the case. Now, the irony is that although Slipher and Hubble came up with these observations, and Friedman and de Sitter and other people came up with mathematical models showing that Einstein's theory predicts an expanding universe, Einstein himself rejected that conclusion. He was firmly stuck in the Aristotelian view of the universe, developed by Spinoza as well, and he firmly concluded it is not possible that the universe is not static, and he changed his equation, he added in an extra term. Now, he's a brilliant genius. He doesn't just add in a term which doesn't belong. It was a legitimate addition to his theory, but it was really not justified. And in the end, he admitted that this was his greatest blunder, adding in this term. He could have predicted the theory of the Big Bang. He would have asked astronomers to make these measurements. They would have found this totally unexpected result of all the galaxies moving away, and the more distance they were, moving faster. And he would have been the originator, and his name would have been associated with the Big Bang Theory. Instead, it's a group of different people who made the measurements and who came up with the solutions to the equations and so on, and the Big Bang Theory is associated with all these different people's names. What's ironic is that we know about Einstein through his autobiography that at some young age he was actually pretty religious and maybe observant. He'd read the Chumash, he studied, he may have actually kept some of the mitzvot, it's not clear to me. At maybe early adolescence, he rejected it all. And he writes that he became very disillusioned with all the stories in the Bible and rejected their truth value. And it's pretty ironic because, of course, the first story in the Bible is the story of the creation of the universe, and basically it might be that his reasons for rejecting the possibility of an expanding universe had to do with this. Why? What happened was when people proposed this theory that the universe was expanding based on Einstein's equations, if you trace things back in time, what happens? It's like the balloon collapsing, right? You see the galaxies moving away from you. Imagine the balloon collapsing backwards, so we're moving back in time. Eventually what happens? All the dots merge. Now, again, we're not talking about galaxies moving through space. We're talking about space itself. We're talking about space itself getting smaller, so that if you went in a straight line in one direction, you come back to where you started. Now it would take you many billions of years. If you would have done it several billions of years ago, it would have taken you much less time because the space of the universe was less. If you move back in time enough, you come to a point where everything is concentrated in one point. It's just one big black hole. And all of space is one black hole. There's not a black hole in space. Now this, again, it's a difficult concept, but there is nothing outside this. All of space, space-time, is now a point. In quantum physics, which Einstein helped develop as well, one understands that you cannot necessarily talk about ordinary concepts of space and time once you get to less than a certain minimum distance. So there's quantum cosmology, which deals with the universe when it's smaller than a certain amount. But basically, you get this picture of a point, and if you run time in the forward direction, you have a point with all of matter and energy in it, all of space and time, and space-time is expanding. In it, the energy in this space-time is turning into matter, is starting to coalesce according to the laws of gravity. Stars are forming, galaxies are forming, and eventually we have the universe as we have it now. Now, the equations also allow us to determine how much time would it have taken to get from here to that. You just trace the equations back in time. How long ago was all of space-time this point? And the number that pops out in the theory of the equation is 15 billion years. And that's where the Big Bang Theory originates, and that's how we get this date of 15 billion years. Now, there are scientific problems with defining all of these terms. First of all, we want to have a theory of the universe. What is the universe? Well, is the universe an entity? It isn't really. It's like a set. There's no such object as the universe. There are entities. Our mental conception, when we think of all these entities together, we group them and we say, this is the universe. But there's no such thing as the universe. Can we have a scientific theory of the universe? Scientific theories, by definition, take many repeated events and study the regularity and the patterns that develop, make predictions, make experiments, verify them, and so on. You can't have many universes. You can't have many originations of the universe. So some people don't even like the term scientific theories of, let's say, the origin of the universe, because it's not scientific in that sense. However, it is possible to make predictions. For example, if there had been a Big Bang, there would be certain radiation permeating the universe coming from all directions as a result of that explosion. And in fact, Penzias and Wilson a number of years ago discovered that radiation. And that gave strong experimental backing to this theory of the Big Bang.
Is there a name for that kind of radiation?
Yeah, it's the microwave background radiation. Microwave background radiation. It's 3 degrees Kelvin. In fact, I think Arnold Penzias is maybe somewhat observant or something.
He's a
like
fun
that.
guy. His kids
Right.
are in Yeshiva.
Yeah, so I mean, it's another example where somehow the people affiliated with some theory certainly don't think that their theory has anything counter-religious implications, but other people hijack it somehow. Now, it's very, very interesting, particularly for the topic that you are interested in. The reason that Einstein rejected the theory which predicted a Big Bang, which predicted a universe which was expanding, was because he felt it had too religious a connotation. And many philosophers of science and many physicists rejected this theory. Why did they hold out? Why did they want to believe in an eternal universe? They knew that Genesis talks about a universe which comes into being with light, with energy, and so on. And they just thought, this is just too religious. And there's a quote, I'm not sure exactly where it's from, but Einstein wrote to some of his colleagues saying that he's not giving in to this. He hasn't yet fallen into the hands of priests. It's partly a reference maybe to Lemaitre, who was actually a Catholic priest, a Jesuit, who was one of the originators of the Big Bang Theory, along with several other people. And it's extremely ironic that somehow the Big Bang Theory afterwards became associated with heresy. It was the quintessential, after thousands of years, where the conception was that the universe is eternal and infinite. Scientifically, someone showed that the universe actually came into being at a certain time. This was exactly what people associated with Genesis. It was rejected by many people because it was too reminiscent of Genesis. And instead of being perceived today as like the most magnificent support for the idea of Genesis, somehow it turned into heresy. And I don't really, and I don't think that, you know, we should fall prey to this. Now, what is the main reason that people think that it's heresy? The billions of years. Okay. The scientists who rejected this theory did not think that that was a problem. When scientists says this smacks too much of Genesis, they say, oh, well, no, it doesn't smack of Genesis. It says, 6,000 years and so on. They saw clearly, and I think we should see clearly, that this is not heresy, it's just the opposite. Now, I don't think we should tie ourselves too closely to a particular theory. For example, the Big Bang Theory might be overridden tomorrow. There are other theories. Hawking came up with a theory of closed time, where you don't have a time development from the beginning, but in the same way that space is closed, time is closed. There are many other theories. Fred Hoyle, at the time that the Big Bang was proposed, he's the one who actually coined the term Big Bang, and he did it in a pejorative sense. He said, oh, the Big Bang, making fun of it, and the term stuck. Now, he came up with a theory which sounds really absurd in the beginning, but is actually pretty logical. He said, no, space is not expanding. The reason that we see this pattern is because there's continuous creation of galaxies. Galaxies pop into existence, and therefore it's not that the universe is getting smaller or larger, it's just that there's more and more galaxies. The space is expanding, but there's more and more galaxies filling it up, so the density is constant. Even if you went back to the past, you would have a similar density, and the universe is infinite. Now, it sounds ridiculous how the galaxies just pop into existence. But on the other hand, if you think about it, if the universe can pop into existence, why can't galaxies pop into existence? I mean, the universe has galaxies, right? So, scientifically, it's actually a sound proposal. But the microwave background radiation that was discovered by Penzias and Wilson put pay to that theory. It was actually scientific confirmation of the Big Bang Theory. Recently, there have been many other confirmations of subtle implications of the Big Bang Theory, inflationary universe, and so on. But there are also other scientific conceptions. Nowadays, people talk about brains, about our universe being some subsection of a multidimensional space. Many, many other kinds of theories of baby universes connected by wormholes and so on. I don't think we necessarily have to tie ourselves to the Big Bang Theory, but I don't think that one should see the Big Bang Theory as anti-Torah. Now, what are the ways that some people have nevertheless looked at the Big Bang Theory and Genesis and tried to overcome, nevertheless, those things that seem to bother some people, for example, the age of the universe? It's very interesting that wherever you look through in the Bible, in the whole Tanakh, you never find, as far as I know, one mention of the age of the universe. The Torah starts out with Genesis and never, ever, ever mentions 2,000 years after creation, such and such happened. Never. If you look, again, as far as I know through the Talmud, you may find discussions of cycles of the universe being 6,000 years, and there's cycles of the universe in the Kabbalah spoken of in millions of years, and billions of years also. No one seems to take this as the date of creation. The only way that you arrive at this number is by counting up, like, how old was Adam when he gave birth to this one, how old was this one when he gave birth to that one, and so on and so forth, and you add up and you get to 6,000 years. But no one seemed to take this date to to be an actual real date. And clearly also when you look at Genesis, for example, the very first word, it says, Bereshit bara Elokim. As all the commentators have pointed out, this is grammatically has no meaning. Hebrew cannot be constructed in such a way, Bereshit bara. It's Bereshit briat, Bereshit bro Elokim shamayim va'aretz, or Bereshit briat shamayim va'aretz. There's no Bereshit bara. It just doesn't, it's in the beginning created. Not in the beginning of the creation or in the beginning God created. It just doesn't hang. And therefore, many of the commentaries, including the very first Rashi on Bereshit, mentions that it should be Bereshit bro Elokim. And you'll find in the modern translations, for example, I think the JPS translation of the Torah, the Jewish translations, you'll see this. Not the famous, in the beginning God created heaven and earth. No. In the beginning of the creation of heaven and earth, when the earth was void and formless and darkness was hovering over the face of the earth, God said, let there be light. Okay? A construct. That gives a totally different interpretation of Bereshit. It doesn't mean we're talking about the beginning. We're talking about in the beginning of things. Clearly the first and second story of Adam and Eve are very, very different, and there are very good reasons why. And one should not just simply understand them in a totally literal way as talking about ordinary time and so on. I mean, after all, does anybody believe that when it says, and God said, let there be light, did God say it? Does God have vocal cords? Was there air? That, I mean, we all know sound is motion of air molecules. Did God create vocal cords for himself and then create air before he created the universe so that he could say something? And who was he saying it to? And what? It's clear that that does not mean saying, as we know it. When it says God saw, does God have eyes? Is there photons of light coming into his brain, into his eye, and being transferred to his retina? I mean, it's absurd. So clearly those things don't mean the literal sense of things. They're very, very deep things, and they have very, very deep meanings. Why should we interpret literally the other things about the days and about... It's not necessary to interpret literally. Rambam speaks very clearly about not interpreting them literally. One can, if one wants to. But I don't think it's fair to say that Judaism believes this in the same way that maybe people at the time of Copernicus said, the Bible believes that the earth is the center of the universe, and anyone who says different is heresy. And then when that theory is overthrown, suddenly people say, well, the Bible can disprove. It's just not true. If a person feels that they want to understand it this way, that's fine. But it is certainly not the Jewish understanding of Genesis is that the universe is 6,000 years old according to our conception of time, and it was created in 6 days, which are days. That's a legitimate interpretation. It's not necessarily the interpretation. And it would be misrepresenting Judaism to present it as the interpretation. Now, there's other ways of looking at this. As I mentioned before, the Big Bang Theory and all scientific conceptions in general neglect deliberately certain aspects of reality that religious people consider to be the most basic and fundamental. Meaning and purpose, love, spirituality, the mind. Those things are totally not in the Big Bang Theory. The Big Bang Theory does not make any mention of any of those. The Big Bang Theory is a naturalistic theory of how the physical universe originates. Now, it says in the Genesis account that God created mankind out of the earth. Now, are we earth? If you go to a hospital, do they open up and take out dirt or blood? They take out, there's no earth. You don't, when you pass through an x-ray, maybe the scanner downstairs, if you walk through, which you're not supposed to, into the actual x-ray machine, do they see earth? If they look at a woman, will they see like a male rib inside? No. So clearly, when did anybody ever think that this was? At the time that the Torah was given at Sinai, did people really think, oh, okay, and inside we're earth? No. Nobody ever thought that that's what it meant. That's not what it means. So what does it mean that God made man out of earth? What did he do then? Clearly, after he took the earth and made a snowman out of earth, he must have turned it all into flesh and blood and cells and genes and stuff like that. Right? How did he do that? Well, it doesn't tell us. Maybe through evolution. Maybe through the Big Bang and evolution. He took the earth and turned it into a human being. We don't know how. It doesn't say how he did it. And clearly, we're not earth. Clearly, at some point, we were turned into this. So maybe science is telling us the mechanism whereby this happened. There are many, 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 many different approaches. There's a tremendous literature about this. And the literature is Jewish and non-Jewish. People have been talking about this idea of the age of the universe for over 150 years, since the time that geologists found that the Earth was millions of years old. By that time, they didn't know it was billions, but it was millions of years old, and they realized that there's some kind of discrepancy. And that's when this whole thing about the age of the universe came up. It never was an issue before. As far as I'm concerned, it's still not an issue. But people have made it into an issue. And again, very, very ironically so, attaching it to the theory of the Big Bang. The religious conception of the universe is that the universe was created as an act of will by a conscious entity for a purpose. Humans are created in the image of this divine entity, whatever that means. And the purpose of the creation of the universe is intimately tied to human activity, maybe the activity of other races elsewhere, we don't know. Clearly, that may have fundamental implications for how the universe came into being. For example, there's a very interesting speculation within quantum physics. It's more quantum metaphysics in a sense. It's not possible to go in this short time into this whole theory. There's a lot of literature about it if you'd like to read. According to some interpretations, it's necessary for the human mind to actually observe something in order for things to achieve the kind of reality status that human minds talk about. And one of the most prominent physicists, Wheeler, whose book I have over here, applied that to the universe as a whole and said, well, how is it that we have a physical universe? It must be that there were observers, conscious observers at some point, to observe the universe in order to bring it into the physical state that we observe today. And his radical conception was that the eventual emergence of observers, of conscious entities, seeing and consciously aware of the universe, is what gives reality to the universe all the way back to the beginning. It's kind of a time loop, a time warp. Something happening as a result of the evolution of the universe then gives reality retroactively back to the origin of the universe. And it's interesting, this is a diagram that I had reprinted in one of my articles, and I had written elsewhere about the connection of the worm Ouroboros, a worm which is swallowing its own tail. And this worm is actually mentioned in the Talmud. In Rashi, I think's commentary, he speaks about, there's a famous discussion about how human decisions transcend nature. There's an article that I wrote together with Professor Brandenburg, which is in this book, which Sylvia kindly obtained from the Wiley Library, and it speaks about that connection between quantum physics and human observers and the collapse of the quantum wave function bringing things into existence. I then applied this together with Wheeler's idea to the creation account. We have the eventual emergence of human beings. The Eden story tells us how humans acquired free will, basically, became conscious observers and chose. And I illustrated it with Wheeler's illustration, where you have the universe developing over time, eventually giving rise to an observer who then observes the initiation of the universe, thereby giving it reality retroactively. And because of the connection of human decisions overriding nature and changing reality retroactively, which I speak about in this article, and since that discussion there is tied into, basically, if you look at it, the worm Ouroboros in the discussion in the Talmud and in Rashi, I tied it in to the creation story and so on, and therefore I was very intrigued when this theme appears so prominently in your work. Altogether, I would say that there are different conceptions of how we can look at the universe. Do we want to look at the universe in a naturalistic way, explaining it with equations and leaving out anything to do with mind, spirituality, art, literature, anything else? Do we want to have a theory which is based only on observation, what can be proven, what is objective in the sense that, as I mentioned before, wherever you're from, whatever you believe, one can do an experiment and prove that this prediction is correct, this measurement is correct. If you want to limit yourself to that, you can come up with incredible things. All of science today is built on that foundation. And so is this incredible idea of the Big Bang, which has been verified experimentally. It's an amazing way to discover a certain aspect of truth about the universe. It's clear if you build a light, you know something about electricity, you know something about light. That's clear. I mean, people who built that obviously got something right. And if you build rockets that go to the moon and go to other planets, you clearly know something about the moon and about the universe and so on. If you can predict that when you look out in the telescope, you will see the galaxy moving away, and predict how it will look when it's the further away, it'll be moving faster and so on. If you can predict something like that based on an equation, you certainly know something about the universe. You may be missing something very fundamental about the universe if you assume that somehow the implication of that is that humans are just incidental. You certainly may be misunderstanding how the universe came into being or why it came into being. Why did God create a Big Bang? Why did God design laws of nature? Why did God design the whole universe in such a way that through these laws of nature, the universe would evolve in such a way that it would eventually produce human beings who would have a mind and would have a spiritual connection, would have free will, and be able to face moral challenges? You're missing the point. But if you understand that science is limiting itself very much to all the things that I mentioned, a naturalistic, reductionist view of the universe, where you're limiting yourself only to those things that everyone can independently verify, you have some aspect of understanding of the universe. If you then complement that with the understandings that come through religion, through revelation and tradition, then you can have a more complete theory. Thank you.
There's some Orthodox physicists I read who dealing with the idea of the age of the universe and the Earth being 4.5 billion years old, somehow bringing relativity to
Right.
something which I never could accept. I studied a little bit of that, and it just seems to be somehow they can't accept like a year is a year. You feel that a year could be 20 years, no reason why it couldn't be.
I'm totally open. There are many, some of the references that I've given in this little sheet for the reading are to one of the scientists who's written on this. I was personally interested in this whole idea, and I came up with several ideas, and then I did some research and read some old books and found that some of the ideas I'd come up with were 150 years old. People independently come up with all kinds of ideas to explain these seeming discrepancies between Genesis and the age of the Earth, and the age of the universe, evolution, and so on and so forth. One of these ideas is that the 6 days of creation aren't days. It's a day, it says in Tehillim, in the Psalms, a day is like 1,000 years, and so on and so forth. There are statements in the Kabbalah very clearly saying that the universe is billions of years old, or millions of years old, different kinds of cycles. There are all kinds of statements in Jewish tradition. My conception of the written Torah, the way I understand it and explain it to people, is that the written Torah is a subset of the oral Torah, and not the reverse. The Jewish people had a tradition before they received the written Torah. They had tradition from Abraham, they had traditions all along, until the time that they received the Torah. Along with the Torah came interpretations of what the Torah is all about. And there are secret teachings which form the Kabbalah, which were never written down. All this is the oral Torah. The written Torah is a subset of that. And to understand the written Torah, you have to look at the oral Torah. And it's very clear when you're reading Midrash and Kabbalah and so on and so forth, that people did not understand these things in a literal sense. Again, that does not mean that it's false. It doesn't mean that one should ignore it. It's very, very, very deep things. To a child, you can say, God saw, God said, God stretched out his arm and took us out of Egypt. And a child has whatever imagery they have of that. We know we have a different vision of that. And if you think deeply into it, you can let go a childlike acceptance of some of the other things that we have, which maybe people haven't really thought deeply about. Which particular way one meshes these things, if one tries to find an equation which shows that from God's viewpoint, 6 days is actually 15 billion years, that's very nice. There are many, many different ways of doing it, and again, I've given a number of references for people who
knowledge, is there any tie to this whole exploration in the Dead Sea Scrolls?
I just have the layman's familiarity with the Dead Sea Scrolls. I'm not aware of any connection. Do you know? Are you referring to something?
No, I'm asking if you read Comic Wars.
I don't, no, I don't know any connection. I don't see why there would be more of a connection to the Dead Sea Scrolls, but I'm not aware of such a thing.
I just want to get back to the balloon with the different dots
Mhm.
and the expansion of this balloon and so forth. In other words, a constant motion, there's constant motion, and the galaxies. Now, all these galaxies, debris, what are they comprised of, first of all? And then when you were trying to tie in, not that you tried, you did tie in the distance with the time. That the further the distance from the time, there was an acceleration of time. Does it ever change, and at what point in this description that you gave, does it constantly expand, and at what point in this expansion does that Big Bang explain what the Bible, and comes close to the Bible's rendition, to the Torah's rendition of the beginning of the universe?
Okay. I'll answer, a wise man answers the first part first. I'm not so wise. I'll just get to the second part first. The basic idea of Genesis, as seen by others, not necessarily as seen by Orthodox Jewish people, was that there's a God who created the universe. The universe came into being at a certain time. Because for thousands of years, the overwhelming majority of philosophers accepted the idea of the eternity of the universe, and they rejected this notion of the universe coming into being. The very fact that the Big Bang Theory spoke about the universe coming into being at a certain finite amount of time ago meant that it had these tremendous religious, biblical connotations. They really couldn't care less about, nobody took that idea seriously about 6,000 in any case. So to all the scientists, the fact that a theory of science showed that the universe came into being a finite amount of time ago and developed rather than being, the ancient Greeks also, because it was an infinite universe, they didn't have a conception of cosmic history. Whatever happened would have happened, kind of like in Kohelet, Ecclesiastes. There was no real timeline, not things working towards a purpose, towards the Messiah, eventual. It was all kind of cyclic and eternal and so on. This idea of the universe beginning and evolving, of developing in time, of greater and greater complexity emerging, human beings emerging where humans weren't, art and literature and science emerging where there was nothing before. This, to them, was totally biblical. Because nobody quibbled about it. Nobody expected that the Bible should have a scientific theory. Nobody expected that science, in order to verify the Bible, would someday come up with a theory that the equations show, in the beginning God created heavens and earth. And this equation shows that God said, let there be light, and then that was the end of the first age. No one expects that science is going to arrive at anything like that. It's absurd. So when they saw this, that the Big Bang Theory predicts this and verifies this, it was totally biblical. Now we'll get to the first part. How do the galaxies form and so on. Once there is something rather than nothing, and this is now a scientific question, why is there something rather than nothing? Why otherwise, sure? And space and time, space is expanding. There's initially just energy. Energy coalesces into matter. Remember I mentioned that matter and energy are really just different phases of the same thing. And you have this matter. Now again, there are more subtle implications of the theory, modern implications of quantum field theory, and the vacuum. There's no way that I can go into that. If people are interested, there's literature for the educated layperson. You don't need a physics background for that. But basically, you have energy turning into matter. Space is expanding. As it's expanding, things are cooling down. This tremendous energy is getting cooler. It's kind of filling a larger space, so it's kind of cooling down on the average. And it's starting to coalesce and clump because of gravity. Now, the reason gravity does this is not because gravity is so much stronger. Why does gravity win out over everything? Why does gravity dictate the size and nature of the universe with the interactions? We know that there are, for example, electric forces. magnetic forces. Why is it gravity does this? The answer is very simple. Electricity, we know, comes in two versions. There's the plus, what we call plus and minus, right? Electrons and protons. Overall, in any given volume of space, there's billions and billions of electrons and protons, but there's the same amount. So they cancel each other out. On the small scale, where there's more protons here and more electrons here, there's strong electric fields here, very much stronger than gravity. In fact, the strength of electric fields is 10 to the 40 times the strength of gravity, which is a number that doesn't make any sense. It's so huge. It's a billion times stronger than gravity. But overall, once you get beyond the atomic dimensions and so on, molecular dimensions, those forces cancel each other because there's just as many electrons as protons and other positive and negative particles. Gravity has only one type, only one charge. And therefore it doesn't cancel out, just the opposite, it aggregates. So the more mass, the more stuff, the more energy, the more gravitational attraction. And it just goes on out there forever, getting weaker and weaker, but as you go out, there's more and more stuff. So it gets weaker and it gets stronger at the same time. Now, this matter is locally aggregating into roughly spheres or ellipses and so on. And those separate ellipses and spheres are kind of aggregating into clumps and clusters near each other. The general scientific understanding, for example, the formation of the solar system, is that you would have a gas of material of dust particles, and it's spinning. And you know from a centrifuge, the heavier stuff will spin out towards the side, and it'll clump together and form planets. And the hydrogen and helium in the center will clump together, and that's the sun. And that's an overgeneralization and simplification and so on, but roughly something like that. Really, the heavier elements come from the interiors of stars that formed previously and then exploded, spewing out their material, and the planets originate from second-generation material. Material that was formed already in stars that were purely hydrogen and helium and exploded and spewed it forth, and then the second generation formed the planets. And so on. Again, there's so much written about this.
I have a question. When you explained very well what causes the circular motion, and you gave the example of a rocket or something being fired at a very high speed, being attracted to the body by gravity. What is the force when somebody doesn't fire it? What is the force that goes this way rather? This is gravity. What is that force?
Those things, again, we had the formation, the scientific understanding of the formation of the planets, if you will, how God caused the formation of the...
That made a noise, I guess. It's
okay, thank you. If you will, how God caused all this to form. Those things which were moving around and didn't have a high enough speed crashed into the center. The Earth is full of craters and outmarks. Look at the moon. The moon has tremendous craters because it doesn't have an atmosphere, so whatever came to the moon actually landed and smashed into it. The Earth has an atmosphere, so things burn up. We see all the time falling stars. What are they? There's matter coming down to the Earth and burning up.
What is the force? What is that force?
So whatever originally in forming, let's say, the solar system, that matter that clumped together that didn't have enough speed to take it around in orbit crashed into the sun. Only those things which had the right speed when they were swirling around and moving and coalesced at the right speed, those things ended up in orbit. In other words, it's not something like a rocket which has an engine moving the force. They initially had a speed in that direction of a certain amount. And it was just the right speed so that they ended up not crashing into the sun and not escaping from the sun, but exactly the right speed to take it in orbit. Everything else crashed into the sun or crashed into the planets.
What is like the correlation between gravity and magnetism?
Well, it's not. Magnetism is a separate force. And we tend to think somehow when you talk about magnetism, we tend to talk about things attracting by magnetism. So we think of anything that's attracting, we say magnetism. But magnetism is a very specific force. And gravity is a totally different force. And this is all gravity. There is magnetism, but magnetism has nothing to do with our being attracted to the Earth. That's gravity. Or the moon being attracted to the Earth.
I know.
years ago, I heard another Orthodox physicist speak about his belief that the Big Bang Theory was a very religious theory, and he actually equated the order in which things happened in Bereshit with the order in which things would have happened in a Big Bang. Like the first thing would have been light.
Right.
I couldn't take notes because it was on a
Okay.
Shabbat. Do you know what I'm talking about?
This other person mentioned someone, and that's Gerald Schroeder, and again, I have a reference to that. This is Nathan Eliezer.
Yes, thank
Right.
you.
There are many other people who've written books, and these ideas, by the way, appeared 100 years ago as well. When people were talking about the ages of the universe, rather than 6 days, they talked about 6 epochs. And they divided 6 eras of time, and they made these parallels. There's a book by Carl Sagan, who was a planetary scientist, and maybe many of you have seen his shows. And he has in one of his books, I think maybe it was a Cosmic Connection, or I'm not sure which book it is, he has a diagram of periods, eras of time. And it was very clear to many people that one can draw these parallels. There are several anomalies. For example, you have vegetation before the sun. How could it be that there's vegetation before the sun? Of course, well, if there's an omnipotent God who can do whatever he wants, he can make vegetation before the sun. You can answer it that way. Or you can say that it's allegorical. Or you could say that the sun shone through the atmosphere. Not that the sun was created before, but the atmosphere didn't allow sun to come through. And this is one of the ways that, for example, Eliezer and various other people explain these things. So you can explain in many, many, many different approaches. And the more you look, you find that these approaches abound, and that whatever approach there is kind of like a recycling of something that existed in some other form previously 150 years ago when geologists first came up with the idea that the Earth is more than what some people thought was the biblical age of the Earth.
What about that religion and science say the opposite about who orbits around whom? The sun orbits around the earth and the earth orbits around the sun.
The church at the time of Copernicus, to some degree, interfered with the development of science, and they burned Bruno at the stake, although historians now point out that it might be more a matter of politics, church politics and so on, than a question of heresy. And the same thing with Copernicus. It's not clear, again, what is the actions of individual priests, or like the witch hunts of Salem, or whatever. Is that really religion? It's not, we won't convince a Protestant that that's Protestant religion. We won't necessarily convince a Catholic. In fact, the Pope came out with a cleansing of Copernicus's name, and Kepler and Galileo and so on. I think it was in 1992. They accepted the Big Bang Theory. They don't have any problems anymore with science. They don't think that any of these people really were heretics, and they said that the church then made a mistake.
But don't we say that the sun moves around the earth?
No.
Doesn't it say that?
It doesn't. No, it doesn't say that the earth. There are things. For example, it says the sun rises. Do we believe that the sun rises? I mean, when people say that the sun rises, they don't necessarily mean the sun rises. When you look at the sun, it rises, but people know that the earth goes around the sun. Now, the truth is that general relativity shows that one cannot make a statement in absolute about relative motion. You cannot say that the sun is standing still and the earth is going around it. And you cannot say the earth is standing still and the sun is going around it. They are in relative motion. All the planets and the stars and the galaxies and everything is in relative motion to each other. Nobody is stationary. There's no one point that is stationary that you can say, this is stationary and this is moving around it. Anyone else can say, no, I am stationary and you are moving around me. There's no absolute space and absolute time and so on. Now, at one time it was thought that there was an absolute space and the earth is the center of the universe. And that I don't think was a religious conception. That was the conception of science or philosophy at the time. Then at the time of Copernicus it switched and they said, the sun is the center of the universe and everything goes around the sun. Then a little later they came to a different conception and said, no, the sun's not the center. Things are going around, and the Earth is going around the sun, but the sun is going around the galactic body. The galaxies are going around something else, and the universe is expanding. There's all these different motions. But basically, the Earth is going around the sun. Then the general relativity perspective is that nothing is going around something else, and nothing is absolutely moving, and something else is stationary. Things are moving relative to each other. And there's a legitimate way to say that I'm standing still and everything's moving around me. So you could say the earth is standing still, everything's moving around me. Have you gained a greater understanding of the universe thereby? Well, I don't know, it depends on what your perception is of the universe. Are the equations simpler that way? Certainly not. If you look at the equations of the orbits of the sun and the planets and the stars around you, very, very, very complicated equations. Very hard to get an understanding of an order to the universe that way. If you understand, if you just say, you know what, I'm going to take this perspective based on what I see these lights moving. These things are moving around me. The sun is rising. Those things are moving. That's legitimate. You can set up the equations, but the equations will simply be more complicated. The fact that they're more complicated doesn't mean that they're less true. Right? If you take the equations based on the sun being the center and things going around the sun, the equations are much simpler. Because equations are simple doesn't mean that it's a more true perspective. They're different perspectives depending on where you're standing. Nothing is really standing still and everything moving around it. Things are moving around relative to each other. There are people who insist that when the Torah says something or other, it does in fact mean that the earth is standing still and things are going around it. You know, that's a legitimate interpretation of Torah. Scientifically, no one can disprove that. But I don't think it's scientifically useful. I don't think it's the correct understanding necessarily of Torah. It's an understanding. Okay, thank you very much.
Excuse me, have you read this?
I've looked through it. There
I find it quite fascinating,
many-
a lot of parallels with
are
what
many,
you've been
many, many
saying.
books, excellent material, and I can refer.
Very,
People
very
are,
interesting.
if people are interested in looking for more
Who's the
sources,
author?
this is a beginning.
Daniel Mann.
And you know, there's just the more you look, the more you'll find that there's discussions on the internet. Discussions sometimes getting very heated between people who have strong opinions, and sometimes it's between people with some scientific training who are just trying to be a little bit more objective. You have to use your own sense to be able to filter out and what to accept and what kind of, just in general, internet, the web in general, you have to use your sense as to what is actually science and what is really religion and what is just somebody's opinion, and so on.
And I think actually, he gave you a kind of introduction to the theory, so when you take people into the gallery and they ask you, you know how to answer it in a simple way. One sentence. Is this something that I can do?
I will try to.
One sentence. God said, let there be a Big Bang.
Right.
Right?
The article, I
What is the
refer
Big
in
Bang?
my, thank you
One
Sylvia for
sentence.
mentioning that, in this journal,
It's a wonderful
the
book.
article in the beginning
Does
is,
that explain
my
the
article
Big
is
Bang,
entitled,
the expansion and contraction?
this journal just came out recently, it's the Torah, and I have an article in there, and the title of the article is, And God Said, Let There Have Been a Big Bang. Which ties into this whole thing that I discussed about the retroactive emergence and so on. If you like, you can purchase this magazine. It's available on this sheet to have information about how to get the magazine. My article itself is actually available on the web. You can find it.
Yeah, I
with this
downloaded
URL.
it. Today. So I can Xerox it for you.
And-
but
Yes,
I'll-
that would be nice.
This other
That would
article
be
I
nice,
mentioned
yes.
about the observer and
To
Halach
what?
and so on, I didn't list it on this.
Why?
I didn't list it on the sheet, but you can find it easily on the web.
Physically or
My
mental?
name,
No.
Halacha and quantum
That,
physics, you
yes.
easily find
But
this
if you
article.
read it, you get like,
Yes.
no.
And a lot of things that he said.
Which one? Jewish Heritage?
It's quite
Are you
scientific.
still there?
We went to the restaurant.
Are you still there?
Yes, I am.
Yeah, me too.
I wouldn't, for me, it's, I must go. It's like something.
Where? Jewish Heritage? Yeah, but I can't be there too much because it's very depressing. No, it's depressing.
talk about the Holocaust to these kids that are in wheelchairs, high school kids.
So what?
So
I'm
these are
getting,
third
wait a
grade
minute,
level.
I'm have something much more problematic.
Yeah.
A group of black kids from Williamsburg who feel that the Jewish community of Williamsburg is antagonistic toward them. Now, how do you explain that one?
Wow, that's a hard one.
Yeah,
What, towards the museum?
what?
Towards the heritage museum?
Yes.
The Holocaust.
No,
No, the children.
Why the kids that are black.
At least they're willing to, at least they're going.
That the Jewish community
Is antagonistic to them.
toward them.
Oh, don't you have the same thing?
Yeah, so then how do you explain that nicely without racial profiling?
It's very difficult.
Just say that it's such different cultures living within a
Maybe
small
it's hard to
area.
understand, but we're not antagonistic, and we would like to get to know you. You have that.
No, we wouldn't really like to get
We would like to get to know you. But you can't say, we like to understand you.
No, you have to go slowly and understand that the people that live in Williamsburg are descendants of Holocaust survivors, and they have
Right, right. So you have to, yeah,
But it's not comedy.
it is hard.
It's very hard. Tomorrow. No, I mean, what is?
You go a different day now.
Oh, I don't go any specific day. I go when they call me. Yes.
What is that? I'm sorry.
From the public school system.
Wide open field. And there are theories that you say you do that in inertia,
And why didn't you fix them? Why? It was the law, it wasn't the came from the law.
So why didn't you use it?
Because it went without, you wanted to want. You have to work with clay. He's Komar. Yeah. You know, I must say, I think the exhibition is very What is your Yeah. And I had probably the most, one of the most fun and not only that, it was, I really went over to work.
Thank you very, very much. We will send you over the arts, okay? Thanks very much.
This is actually my brother's address. I live in Manhattan, but that's not my brother's address.
Now we're doing something else, I was happy to see it. Now, what is your, that's your exhibit that is relevant to what they were.
It is the same title, origin.
Yeah.
No, you can easily write it in.
You cover
Okay, thank you. Your name is?
October 24th.
So that's this Thursday.
I just want to ask you.
You, but it will be during all February. You can visit it.
No, I'm still giving, I'm giving inventory. It's not, what is that? Is it in place now?
Mostly.
Is it the evolutionary theory like talent?
Because many possible questions which people, visitors will ask, will answer. We have answers for all.
So you have no doubt that.
With Rico's house, by Tower Komar, and,
Actually, I have a Xerox of this.
I have a
If you read it, you will understand all question for your visitors.
Like you said,
Both
go
sides.
into the origins,
It's
you know, okay,
each
so it doesn't mean
each
dust,
paper
that
has
person
both
was
sides.
created from dust. Right.
so you're going to meet us Thursday? What
Yes,
time
it will
Thursday?
be from 5 to
Does
6.
it come via evolutionary?
The only
From 5 to 8.
problem that would be with the evolution.
But I will give something else. I will give something else just for my friend. Just some friends. It depends on them. When you ask me, I will.
And what about?
Nobody says evolutionary theory contradicts the fact that
Now he's not in New York.
if humans evolved as Earth, it was God breathed the soul into the creature.
Because now he
Yeah, but if they
moved
evolved
from
from
one
animals, what, then he took that man
apartment
and
to
just
another
learned, so
apartment.
he evolved in the resident.
He must
Animals,
be.
if animals don't have souls.
Animals don't have
He was
souls.
So then some.
And it says so
some-
in Bereshit.
Souls, but if humans came from animals, it says that God breathed the soul.
And also it was published book, Art of
So when man
Century.
evolved, God breathed the soul.
Just 100 artists.
Otherwise, he would just be an animal, like an animal. He would be without spirituality, without.
But you know,
without
it's
maybe
the
conscious.
so you have no theme on the sea is changing the way time.
It's true.
Your model changes, it's more like it's
I
hard to
don't
explain to people their installations. Because some people come here.
Contradict anything. I mean,
and more
it certainly
the flower
contradicts
comes in,
Bereshit
they
if you
want
interpret it
to
totally
fake
literally.
from
No, I know
But-
it's difficult to
We have
interpret
4
the
paintings.
And they make it, they have to get used to the idea of
We
installation.
have 4 paintings on the show
This you
and
go through Bereshit.
2 dozen
How could-
drawings.
You know, if you're logical, you
If
just.
you look at
And
And
we,
that's installation.
we give an
It's
artistic
not
rendition
true.
of what, Professor Rabinowitz
Any,
just.
look at any measure, you see it totally
That's an
contradicts
artistic.
Bereshit.
So it's not like an installation like you had.
It's not like
The
installation.
first story,
It's
look
not
at
like installation.
Go home, read the creation
It's
story.
traditional show.
Totally
4
different.
paintings,
Oh, I love it.
4 paintings, 4 paintings and 2 dozen of drawings.
Different story.
So where in Kabbalah do you
It's
see,
different.
Yeah.
We're doing many
what, the
different things.
Medrash?
We're doing public
Where
sculptures.
is that, what is the
We're
source?
doing
Other many,
performances.
if you look at these
This
sources
is
that
not
are
really about the source.
that just get a
You
top
mean
source sheet.
act out of a painting?
Something like that, but
Oh, with
slides.
Medrash,
Oh,
yeah.
Kabbalah, so you have that
Source.
other source.
Yeah.
Also,
There's any
doing
information you
poetry,
want.
we published the book.
Challenge.
So what, that's your source sheet that you
I
have?
just some further reading.
So who has that?
Sylvia says she just wants to copy it
To give out, oh, okay.
There's, you have any amount of reading, any amount of sources. It's just a smattering of sources because it's a vast literature. So,
Thank you.
you're welcome.
Professor Rabinowitz, I just want to